Hello everybody. This is a quick video about the new R package for PsyToolkit. I'm going to show you quickly how to install it. You can get it from the website, from the PsyToolkit website, and how to use it. Now, it comes also with a demonstration data set, so it should get you going. The website will be gradually developed with more examples. We are now March 2025 and it's all just new. We did a live stream as well so that people could ask questions. I'm expecting feedback from people about um, the new R package. Um, let's see how things go. I just want to show you now how to do it, and I take the image of myself here away from the video, so just to make sure you can concentrate on the coding. And so what we do here is, so if you're on this link, and the link is below this video, and let's assume this is your R console. Now, different people use different interfaces for working with R. Ultimately, R is a scripting language. There are different packages around there that you can use. I use something called Emacs. Emacs speaks statistics, but you don't need to use that. You can use whatever software you use. Now, if you watch this video, we assume that you know a little bit about R, but let's first see what it says here on the website. So in order to use this package, you need to install it. The package is actually on the PsyToolkit server. So if we copy this and if we install it, all you need to do is here, you type it and you let it run. Then it downloads the package and installs it. It is actually a really small package. It has no further dependencies on other packages, so it shouldn't be difficult to install in your local hard disk. In future, we might make this an official R package, but we're not there yet. I just am waiting to see what people think about it. And if you have any suggestions, please feel free to contact me. Uh, so once you have installed it, you can use it by typing library PsyToolkit, as with any other add-on package that you use in R. And actually, there are not that many functions in it. The important functions that are in there start with PsyTK actually. And then if you, at least in my R system, I can type tab to actually see what's there. And there are 8 functions that start with that. And of those, the key one to start with is actually PsyTK read data. Now, it assumes that you have data. So you can download, of course, your own survey data from your PsyToolkit account. I have already downloaded a package, and I'm using Linux here, so I'm in the command line mode. But if you look at sort of like a file manager, the way it looks like, I have a directory actually called demo that I'm in. And in demo, I have one folder with the PsyToolkit data. This is basically when you prepare and collect your zipped data from PsyToolkit. You need to unpack it here in this folder or wherever you work. And then what you will get is you will have 2 subfolders, namely, you will have experiment data only if you include experiments, but many people do. Uh, you have your survey text, that's your script that you use, that's always useful to look at, and you have your survey data. Now, every participant or every person who runs a session on PsyToolkit always has a file like this. It starts with S for survey, then with a very long, what we call a universal unique ID, and it's a text file. So if you open one of these, you just can look at that. But ultimately, you it's the information people entered, but you don't need to understand that. On the website, actually, it's explained how these files are structured. But what matters here uh, really is the following. Um, so, the the PsyToolkit library actually does this all for you. So it reads in all the structure of the survey and all the data files. And I'm just saying this, so make sure that you have uh, a folder with your data in it. So because otherwise it's difficult to read it in. Right? Okay, you need to have your data somewhere, and you would have that on the computer that you're working on, your laptop or your desktop computer. So now I have a folder as you saw, which was called, wait, I can look here, PsyToolkit demo data. That's where my files are in. So what you do first is PsyToolkit read data, and then as a string the name. Oops, sorry. Let's go there. The name of that folder. I'm just inside. Yes. So that's the name. That's just an Emacs thing. So I just wanted to copy that. Site tk read data, and then I need to give that a variable name. Now, in R, people often use this as what we call the assignment operator. But in R, you can use the equal sign. I find that personally much easier to type in, so I always use that. D equals scitk read data and then the folder name. And then the nice thing is, it reads all the files. And I'm not going into the details. So sometimes what people can do is they can go back in the questionnaire and even do an experiment a second time. You can ignore those or you can take them in. I've allowed that to happen. That's quite rare. I think there was just one participant who somehow did that. Um, then if you want to know what's in D, you can um, you can D dollar sign. Yeah, that is in standard R or in base R. D is actually a list, and a list has components. And in our case, so let's first look at these. So one of them is n, and that's actually quite useful. So then you can see how many data how many participants are there in. There are many more data files. So in this specific case, we also can look at our survey itself. Let me see where it is. This is called survey object. If you look at that, you just see that it's organized as a list. If you do that survey object, you get an overview of that. It says sort of like what the labels are in your PsyToolkit survey, the type of questions, and how many items they had. And you can see that if you look at the actual survey um, which we can load, this was the actual survey. So you see we had a question H, right? And if you look here, it has this question here. It says the text line had one item because there's one thing that people could enter there, and so on, right? So you can look at all these things. Now, so you could even do this. So the survey object, again, that is a list, and then you get an overview. And that's quite nice, actually. You get all the information. What is also really useful is the function scitk report data. The report, then let's see. So if you scitk report, that creates a human readable output of the labels that you have in your questionnaire and the answers, if there are any. And that does that for all items. And in this case, for example, we had a question H, which was a text line. The age ranged from 18 to 82. There was numerical input, and then you get also the mean and the median. For a multiple choice or radio question, you get something like um, you know how many of each. For a scale question, for each item, you get the mean score, and it shows you the item. So this is actually quite nice, actually, for having a quick overview of all the data that you have collected. I really like this. I think this is, for me personally, I find it easier than actually you get a report on the site toolkit interface on the website itself as well, which is pretty good. But I like to do these sort of data offline, and there you go. Get all the questions. Now, uh, if we quickly go back to our website with the explanations, it explains these functions. So what we have done right now, we have PsyToolkit R read data. That's when you know where the folder is. There is a way to just read in the questions themselves without the data. It is, I, ultimately, um, there might be very specific cases where you would use that, but I'm not sure that's that useful. So, but you can play around with it. Um, so let's do that. For example, if instead of read data, so remember where we had this command here. Let's see if we do say instead of say parse survey, then P, uh, then just that is just basically this also part of the that gives you this overview, but it doesn't read in the answers. Okay. Okay. So the report we have seen. So this block now has been explained. Now I think that I just want to, yeah, probably, how would you use this? I mean, I just probably want to give you one example output. So for example, if I look at my demographic data, how do you deal with that? Well, what can you do? Well, what you can do in R um, is something like this. You know, if you look at the and you see there is something like text line answers. So we only had one text line answer, which was called age. So I can let me see if I can do this. This doesn't work. Uh, age that works because this is with R. So the dollar sign refers to named items in a list, and then this is actually a data frame, and then this refers then to a column. You need to know a little bit R to feel comfortable with it, and sometimes it's really just playing around with it how it works. Now, if because that is a lot to write, it's always useful to do something like just create a new variable, right? Age, call it just age, and then you just have the numbers, and then you can do things such as get a histogram of the age, for example, which in this case creates a different monitor, and then you get a quick histogram, just to get a quick overview. You see, most people are between 20 and 30, which is not surprising because most of the people that will participate in this are Um, some are undergraduate students, but there will also be many postgraduate students who are doing a master or a PhD degree. What you can equally do, so we have this radio questions, the radio questions. Now, radio answers. If you have radio answers in your survey, you get now. I had only one was called gender, and it was numbered, right? So it was one was female, two was male, and again. I always like to make uh, um, so like vectors of that. So for example, I know there are 164 participants, and then if I want to say do something like this, female, what this is a vector of false and true. And then I can select, for example, just the female participants, or I can, so for example, if I want so I have now age, right? If I want the age of only female participants, then you get this, and then you can in R do something like this. And did I need to make sure I created them all. So let me see. You can also, if you have all these variables, of course, you can also do T apply, which is you get the median age of female and male, which is interesting actually. They were 5 years apart in this survey that we did. Now all these data, participants, we only include data from participants who had said at the end that they still consented to using these data as part of this teaching exercise. Now, let me, so, and basically you can play around with these data. All your data are in there. Just look, for example, if you go to set answers, you find we had a scale question, and then we had set answers to calculate extroversion, agreeableness, conscientiousness, and so on. And then you see for every participant the answers. Now, this is all really nice to analyze your survey data. So that is hopefully clear enough. But I appreciate that. It takes a little bit time probably to play around with it, and I want to make these R files actually publicly available also via the website. They are not yet. That's why I make this video. But um, so uh, now let's have a look at some of the as the final part of this video. Let's have a look at some of the data for the experiments. If you have experiments, there will be something called in D, right? Your data, X data dot, and then the name of the surveys. Now, sorry, of the experiments. And we had an experiment Stroop for R. That was just the name of the experiment. If I go to my, so if I look at it, right? So there was Stroop for. See, this was in the survey. The experiment was called Stroop for R. I just because that's just how I named it. For the R package, so to speak. Um, and then but that's a huge actually data frame. If I enter, it outputs so much data, and then it says, okay, at 6,250 basically, it ends. Uh, Too much data. But if we do, as you can do in R, like dim, right, the dimension of the data frame, you see that there are 11,152 lines and 16 columns. So what we can do is we can get the head, so the first lines of that. And also, by the way, so if you want, I can. So if I do it again, then it won't break the lines because I have a wide screen. Um, so what you see is I've multiple columns, but what PsyToolkit actually does, it adds two columns. So it adds ID1, which is the long ID of the participant, and ID2, which is the short ID. This is somewhat arbitrarily assigned, just one, the first participant, the first data file it finds, it gives one, so that every participant has an easier ID. But these are unique IDs, and we need inside to look at unique IDs because sometimes people can start exactly at the same time, and that's why we do that. And we only want to analyze some aspects of this, but what we want to do is from every participant we want to extract data, and for that we have a function PsyTK extract a num. Okay, then if you type it out, you see the whole function. But so this, and by the way, the help doesn't work, so we haven't installed this package. Does not come with help yet. Will be added at some point, but you can go to the website and learn about it. But if I go to my Stroop, so this is one that I want to explain here. Stroop, run me first. So here, actually, I apply that, and I want to explain how it works. So first, actually, so we have this data frame. That's part of our data. So this one, and this has all these columns that have a meaning. Now, what the meaning is depends on, you know, what data you have saved with PsyToolkit. You do that with the save line. And in this case, so, well, I said these were added. So we have the first line is the block number, which was training or real. Then we have the color of the word, the color of the ink, or the other way around. Then where is congruent or incongruent? Well, the condition, this is not important. This one is not important. I think this is where it's correct or not. So 3 is wrong, or this 3 is timeout. 1 is correct. So we want that this is correct, right? So we only want, for reaction times, you only want correct trials, and this is the actual response time. So this is the 10th column in this data frame because like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So now, what I've done here first, I have here some I create some logical vectors to select specific rows of this data frame. Now, this is one way of filtering data. This is in basic R, and it's quite nice. So, for example, if let's have a look at it, right? So, remember, if we look at this, right? So we know that column V7 corrects. If it's one, it's correct. So what you do here in this line, you say you create a new vector that contains true or false for every row. If if it's if it's one, it's true, and otherwise it's false. And that's nice. Then you can true correct, right? So you have true correct. Um, if you can even do something like some true correct, then okay. So of those, so of all, remember that we had uh, the dimension of the whole data frame. What was that? So that was oops. Wait, what happens here? Uh, hmm, that was okay. So 94% of the responses in total, of the across all participants was 94% correct. Now, typically that's how you analyze your data. You do it at a percent at the individual level. So what we have therefore a couple of functions to do that. So one is to extract numerical data, and that is this function. And we need to say what is the data? Where is the data? What's the data frame? Well, that's this one. xdata.strup4r. What is the column of the of the reaction time of the basically in this case what column contains the reaction time, which is the 10th column? What are the names that you want to give to the conditions? I want to call them congruent and incongruent. And then I basically just add there a uh, basically two columns which contain for each row the congruent, what is congruent or incongruent. So if you would take this on one line, I'd show you what it would look like. Let me just hold on. If I take this here, right? So let's just put it on one line. If I would, for example, create it in a new variable which I call set. That doesn't work. Too many brackets. Wait. Oh, I haven't. Okay, that's this. I need to. Sorry, I need to run these first for these variables to exist. And I'll run that here in Emacs. You just type Control XR and then okay. So now what does that look like? So for every row, we have 11,152. For every row of all the participants of this combined data set, we have whether, the first column is whether it's congruent or incongruent. Now some are neither because these are actually in a training block. So if you if you look at the xdata strup4r, if I actually would combine that, I can with z, um, and then take the head of that. So what you know this is one of the nice things you can do with R, right? Very easily. If I look at these, false false because this is in the training block. So training false false, training false false, training false false. But then here real, and then it says okay, this is incongruent, and so on. So basically, conditions is essentially because I say there are two conditions. I have two columns, one for my first condition, one for my second condition, and there, if it's true, then that 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 the trial basically is one of the conditions. So now this requires some skills with R vectors and data frames and so on. But I hope that it's clear. If not, I might have to do another lesson on that. But I have something similar for extract percentages, just um, and then and in the end I can calculate the Stroop effect per person. So I have, if you know, because now if I have this for every participant, because I run this, so I run this Stroop RT function, right? So now for every person, and there are 164 lines. For every person, I have a response time in the congruent and incongruent. And the nice thing with that is you can do things such as the t-test on that, where you the first column, or congruent if you want, and then Stroop RT incongruent. Now don't forget this is paired, right? So you said paired equals true, and then you get that is highly significant, right? So and that's nice. In order to do that, so you need to have this. You need to basically anal get all the data for each participant. There are different ways of it. So in the example data, I also have so there are more sophisticated ways of doing it. You can do it with a multi-level model and so on. I explained it as well. I need to make that available to everybody. So by the time that you watch this, that might already be up there. So I hope that's clear. That gives you a start. Uh, if you have any questions, please email me, because what I really want is that people who use R can use this offline data analysis, which many people already do that, but it doesn't make sense if everybody needs to reinvent the wheel to write this sort of code. So I hope you found it helpful, and if just again remember, look at this website, and that's where all the information is. And that's it. Bye bye for now.